Hello, chemical systems. Today we're going to talk about elements, compounds, and mixtures. So we're going to talk about what they are, difference between them, and how to know what you're dealing with. So all of this kind of comes down to the fact that our world, all matter, is made of these things called atoms and molecules. These are the tiny, tiny pieces of things that make up everything around us. You guys watched the video that this counter is made of molecules. My hand, the air I breathe, the water coming out of my sink, it's all made of molecules, which are very tiny, tiny pieces of matter that are responsible for, well, all the chemical reactions and all the reactions that we need to survive, and then some. So you can kind of think of them as like Lego pieces. You can join them together. Sometimes if you try to put them together in certain ways, they won't fit together. Atoms and molecules are like that too. So in the coming weeks, we're going to learn about the atomic structure, what an atom is, and how they make molecules and what molecules are. But for now, we're going to focus on elements, compounds, and mixtures, basically how another way of thinking how matter behave. You guys learned about solids, liquids, and gases. Well, now we're talking about another way to look at matter, which is by the ways that they behave. So sometimes matter is made of a single substance, a single pure substance, and it's so pure that I can't break it down into something different anymore. If I could break it apart into smaller pieces, but no matter how hard I try, it's still going to be the same thing. This is still going to be blue no matter what I do. Take, for example, iron. Iron is a pure substance. Iron is not made of different kinds of things. It's just iron. And the same with graphite. Graphite is a single pure substance. Now, graphite, if you can't tell, that's what we call the lead in our pencils. They used to make pencil out of lead until they realized it was poisonous, and kids can be putting poison in their mouth at school because they're bored. It's not good. Anyway, so elements have different behaviors. For example, iron is magnetic, and graphite is not. Another element is oxygen. You can breathe in oxygen and use oxygen to give your body energy. Not true with graphite or iron. You need some amount of iron in your body, but not nearly as much as you need oxygen. So we call these things elements. Elements are those things that cannot be broken down any further. I can break them into smaller pieces, but these are pure substances that I cannot break apart. There's no chemical reaction that I can use to break them down any further. So having talked about elements, let's kind of move to the next part of our discussion to talk about a couple examples here. So here I have water and I have salt. If I were to ask you, well, are these pure substances or not? How would you know? Well, you really couldn't. So the discussion of whether something is an element or not took many, many years of research and trial and error to figure it out. It turns out that water is a combination of two elements, hydrogen and oxygen. So hydrogen and oxygen put together make what we think of as water. So this glass of water is filled of billions of water molecules. Salt is also made of two elements, sodium and chloride. Sodium and chloride are what we think make table salt. So when we have two or more elements that come together that bond chemically, they're actually bonded together chemically, we call that a compound. So an element is a pure substance. Can't break that down any further. Compounds are combinations of one or more elements. And now with compounds, I actually can't break it down to one or more elements. I can put water through something called electrolysis and break apart the hydrogen from the oxygen. Now, water is kind of interesting because hydrogen is a gas at room temperature. Oxygen is also a gas at room temperature. But when I combine the two of them together, which is an extremely explosive reaction, I get water. and which is liquid at room temperature. So when we combine elements, they have different properties when they're combined with each other. They don't have the same properties as they used to when they were alone. And again, those kind of things just kind of take years of study, which is why you're in this class, to kind of study along and see what other people have learned. Now, let's say we wanted to put these two compounds together. We want to put salt and water together, which we do all the time in the kitchen. We put salt and waters together as we cook. We mix things together. So I'm going to put the salt in here with the water. And I don't know if you guys can see it, but you can kind of still see the salt. But if I mix it up enough, it begins to look like they become one and the same. So it's dissolving now. So the salt is not actually bonding with water here. So what's happened, I don't have this going on where they're clicking together and making a new compound. These are actually all the salt molecules and the water molecules are actually kind of just floating around together. They're not bonding together, but they're just together. In fact, the chloride and sodium atoms at this point might actually be separating. This is called a mixture. So a mixture is when I mix two or more things together. It could be an element or a compound, or two elements or two compounds, whatever, but they're not actually chemically bonding. And I'm not actually having bonding going on here. And so a mixture would just look like that. So remember, a compound is when I actually have a chemical bond. Their elements are bonding together. Mixture, they're not actually bonded together. They're all here together in this glass. I now have some salt water, but the salt and the water are not chemically bonded. That's what example of a mixture is. So just to kind of review, elements, that's when I have a pure substance. I can break it apart in smaller pieces, but it's always going to be the same. I can break these iron screws further down and down and down, but they're always going to be iron. I can't find smaller atoms of something different. Compound is when two or more elements join together to make something, and they chemically bond, like the example I gave you was when hydrogen and oxygen come together to form a molecule, or when sodium and chloride come together to make a salt molecule. Those are called compounds. And lastly, a mixture is when I mix two elements or two compounds together, and they don't chemically bond, but they are mixed together. Now, there are lots of different types of mixtures. I hope you guys I still want you guys to go through the readings today to read about mixtures. There's lots of different types of mixtures, but I just want you guys to realize that mixtures and compounds are not the same. Compounds are when they're actually bonded together, and we'll talk about chemical bonds. Mixtures is when they're just kind of together. Now, I might hear some of you guys might be thinking, well, you just showed us how to make a compound, but you never really showed us how to make, or sorry, you showed us a mixture, but you didn't really show us how a compound is made. So let me show you a couple of examples at home that you can make with a couple of compounds you can make easily at home. Because we have oxygen in the air around us, but there's a tiny bit of hydrogen gas, but not a lot of you guys are going out to buy tanks of oxygen and hydrogen and then lighting them on fire and putting them together to make water. That's extremely explosive and extremely dangerous. So let's talk about a couple of compounds you can make right at home. Some of it's being made without you having to do anything. For example, here are some other iron screws, but these are rusted. So what's happening here is that if iron is exposed to too much oxygen, they will chemically bond and make a new compound. So iron plus oxygen makes something called iron oxide or rust. And iron and rust are similar in that they're both magnetic, but I'll show you here. They're both magnetic, but they don't, rust is very brittle. If you're going to make something out of rust or iron, your top choice is probably iron, right? Another compound you can make is through a combustion reaction. A combustion reaction is basically whenever you use oxygen to burn something. So like a match, for example, I have a match. So for a combustion reaction to work, you need two things. You need oxygen and you need a hydrocarbon. Hydrocarbon, we might discuss much later in the course, but in the tip of this, this match is made of wood, which is made of lots of hydrocarbons, which means I can combine the two to make something new. So this burning, excuse me, and I have a cough too. This burning here is actually creating something. The match went out. When I burn something, the hydrocarbon and the oxygen are combining to make carbon dioxide and water. So whenever you burn anything, you're actually creating water along with carbon dioxide. And there's lots of soot too. I blew that one out too. So those are two examples of compounds that can be made at home. So again, that's elements, compounds, and mixtures. Hope that helped you kind of visualize what those three things are. And I will talk to you later. Have a good day.